This lesson is on the inverse cosine function. If you've already listened to the inverse sine function, then you know the basis of why we're going to restrict the domain. But before I actually do that, I'd like to be a little bit more detailed about what happens when you apply a horizontal line test, there we go, to the original function. Once again, you'll see it crosses here, 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 meaning that this graph's inverse, which would be a reflection over the identity function, would not be a function. You know, this time, let's actually look at a reflection of a cosine graph over that identity function y equals x. We'll turn off the original graph. We'll turn off the horizontal line test. Now flip on the vertical line test, and you can see that this reflection in its purest form of the cosine function is not going to be a function. And that's bad because we're only allowed to get one answer out if it's going to be an inverse cosine function. So off this goes. Goodbye, graph. There we go. In fact, let's just delete that completely. Turn on the original cosine function and let's do some restricting. How about we go from negative pi over 2 and we go to pi over 2. These are the same restrictions that we applied to the sine function. And of course, this will work until you realize, uh-oh, I have all my positive ratios covered, and unfortunately, not covered just once, but twice based on the horizontal line test. And even worse, I have no answers that would come back if I ever had a negative ratio because this graph never goes below. So if I'm going to do restrictions, I want to make sure I cover 0 degrees to 90 degrees because, again, in a right triangle, that's all the angles you're going to need once you eliminate the right triangle here. So let's clear this all out. Let's try some new restrictions. Let's have it go from 0. Let's have it go to pi. By doing this now, you'll see that here I have positive ratios, I have negative ratios. Apply a horizontal line test as such. Crosses only once. Ladies and gentlemen, I believe I have found what I am looking for. Now that I've restricted the cosine function from 0 to pi, let's take and reflect the green graph. Let's turn off the horizontal line test over the identity function y equals x. If I do this correctly, I should get this nice red graph right there. Let's turn off the identity function. Let's turn off the original cosine with its restrictions and realize that I now have a graph that looks like it's going from a height-wise of 0 to something over 3. Of course, it would be a little easier if I remember that these are no longer angles anymore. So let's change the x-axis. That's not what I wanted. Let's try this again. Change the x-axis to 1. Change the y-axis to pi over 2, and you can get a better idea now, so when I draw this out, that this negative 1 to positive 1 is also my domain of this graph, which of course are my ratios that I can put in. This height of 0 up to this height of pi represents the range of angles that I can get out. Of course, remember, that could mean 0 degrees to 180 degrees. Again, a cosine inverse, let's make sure we actually write that up there some way, or also known as arc cosine of x, is going to have no asymptotes, and symmetry-wise, there is a point of symmetry right there. The point of symmetry happens to be at 0 comma pi over 2. The key is it's not symmetric with the y-axis, so therefore this graph, our cosine, is not an even function. And it's not symmetric at the origin, so it's not odd. So I guess it falls in one of those categories of neither. But this is how you restrict a cosine function to produce a cosine inverse. The advantages to a cosine, which you didn't have with sine, is that if for some reason you have an angle that's obtuse, that's because the ratio of that angle would have been a negative value, a negative ratio. And since you are allowed to have answers come back to 180 degrees, this can give you not only just the acute angles that work in a right triangle, but will also work in all triangles that we're familiar with up to 180 degrees. So there you go. There's the properties of an inverse cosine function.